We're going to learn how to apply multiplication and division to surds, and we'll be doing that in order to simplify expressions, and make calculations too, I might add. Some things to remember, and not all of this is new. When multiplying surds, we must use these results here. So we've seen this in our previous work. We've actually tended to apply it that way in our previous work. Obviously, it can be applied that way as well. So, in fact, that's the way we'll be applying it in this video. An extension on that is that if instead of just having root x and root y, if you have a times root x times b times root y, you can write it like that there. So in other words, all of these things are multiplied together, and because it's commutative multiplication, we can change the order. So all that is just a rearrangement. We've grouped the constants together, the real numbers, the rational numbers, and we've grouped the surds together under one radical. So that's an important result as well. Dividing. Division, sometimes this result here, or this property, is useful. So root x over root y is root x over y, and there's implied brackets there. Sometimes you should even put the brackets in. An extension on that more generally is if we add in some constants there, we can group the constants separately and group root x on y as per the previous result. So it's a over b times the square root of x on y. Now you recall the distributive law from our work in algebra and in real numbers. Well, it also applies in surds as well. When we expand, we often expand so that we can simplify an expression or an equation. Now to perform 3 examples to demonstrate the properties. Okay, the first one on the left, simplify. So we're simplifying 2 root 3 times 3 root 15, and we can reorganize it. So constants, 2 times 3 times root 3 times root 15. Then we can apply some simplifying strategies. 2 by 3 is 6, and root 3 times root 15 is root 3 by 15, all under the same radical, which is 6 times root 45. Now, don't get fooled into thinking that's the final answer, because you can further simplify that. If you think about our previous work, if you were presented with something like this, you could simplify it. In fact, that might be a question from the previous activities we've done. You know you can simplify that, so don't stop there. Now the 6 can't be simplified, obviously, but square root of 45, remember, can be written as a product of one square number, one square factor, 9 by 5. So we're actually reversing the process in that step, but we're using different factors. So we split that, and 6 times, now that's a times, square root of 9 is 3, root 5 is a surd, it cannot be reduced down, 18 root 5 is the answer there, 18 root 5. Second example in the middle there, we have 12 root 18 divided by 3 root 3. If you like, you can arrange that as a fraction. That format might make life a bit easier. And we have 12 root 18 over 3 root 3. Now we can expand the square root of 18. So we have 12. What can we do? Well, we want a square factor. 9 is a square factor of 18. 9 times 2. The denominator stays the same. And now we can remember that one of the laws said we can pull the constants out as their own fraction, and we can separate that into square root of 9 times the square root of 2 as its own fraction over square root of 3. 12 divided by 3 is 4. Square root of 9 is 3 times root 2 over root 3. Now, of course, that's all times. We can move the 3 with the 4. Sorry. Let me put that square root there. So if we're careful, we can merge those two fractions together. Okay, when multiplying fractions, we multiply the numerators together. That's 4 by 3 is 12, and there's a root 2 there, 12 root 2. 1 times root 3 is just root 3. Now at this stage in the game, that would be an adequate answer. It's not, truth be told, not actually the best answer. We haven't covered rationalization of the denominator yet. There's another way of doing the same question where you'll get an equivalent answer that is actually slightly simpler. So here's another version of this question. So 12 root 18 over 3 root 3, and following one of the results we looked at before, we can do this. Group the constants and the surds as such. 12 divided by 3 is 4. Now under the radical sign there we have 18 over 3. That could be written as 6, so it's 4 times the square root of 6. Now if you put, those answers don't look the same, but they are. If you put them both in the calculator, you'll see that they're equivalent. You can see the second one is a slicker process, and it is a slightly better answer. Later on, when we do rationalization of the denominator, what we'll do is actually multiply the top and the bottom by root 3 on root 3, which is 1, and so we get that there, the answer, and times it by root 3 on root 3, which is 1, and then you get 12 times root 6 over 3, or 4 root 6. So it's the same answer, but the second method is a lot quicker. Let's do the last one. We're going to use a distributive rule, so first by the at the outside entity by the first minus the outside entity by the second. So that means we've got 3 root 6 times 2 root 10 minus 3 root 6 times 4 root 8. One strategy you can use is to go the constants times together for the first term. So looking at this first term here, we've got the constants are 3 and 2, so that makes 6 when we times them together, and the root 10 and the root 6 make root 60. Same with the second term, 12 root 48. Now that's not simplified. We've done the expanding, but we haven't done the simplification fully yet. So we're looking for factors of 60. One of them needs to be a square number. Well, 60 equals 4 times 15. 4 is a square number. (12) times root 48. 16 by 3 is 48. And that'll be 6 by root 4 by root 15 minus 12 by root 16 by root 3. Okay, we evaluate the square numbers with the square root signs on them. So square root of 4 is 2, so 6 by 2 is 12, root 15. And then we've got Root 16 is 4, so 12 by 4 is 48. Root 3. Now we just need to do a final check. Is that simplified? Let's have a look. Well, the 48 root 3 is simplified. 15, what are the factors of 15? 5 and 3, 1 and 15. Well, none of them are square numbers, so that's settled. So it's 12 root 15 minus 48 root 3. Multiplication and division of surds.